Welcome to the deep dive. This is where we take a whole bunch of sources and really pull out the key stuff for you.
Yeah, we sift through it all so you get the insights without, getting totally buried.
Exactly. And today we're jumping into a really big topic, sustainable building design.
It's a huge field. We got some great material, mostly drawing from the Whole Building Handbook. It's kind of our guide today.
Right. Think of it as a way to understand how buildings can be, well, more than just buildings. Healthier, way more efficient, and better for the planet.
That's the goal. Our mission here is to explore the core ideas, the practical bits, so you walk away with a really solid feel for sustainable building.
Without needing a PhD in it yourself.
Mhm.
Okay, let's get started. Where do we begin?
Well, you really can't talk about sustainable building without setting the stage with the bigger picture. And that picture, according to our sources, is definitely climate change.
Okay, the elephant in the room.
Pretty much. We're dealing with this enhanced greenhouse effect, more gases trapping heat, and the potential impact. Global temperatures could rise somewhere between, say, 1.6 and maybe even 6 degrees Celsius.
Whoa, 6 degrees.
Yeah.
That's massive. And that temperature rise, it causes other problems, doesn't it?
Absolutely. It's not just about feeling hotter. We're looking at potential sea level rise. The predictions range from 15 to 100 centimeters.
Whole meter, potentially.
Potentially. Plus big shifts in climate zones and what we're already seeing more of extreme weather, more intense storms, floods, droughts.
Yeah, you see it in the news all the time now.
Exactly. And the social and economic fallout from all this could be enormous. The Stern report back in 2006 really hammered home the economic case for acting on climate change.
Right, so it's not just an environmental issue. It's a huge economic one, too.
Precisely. And our sources point out that even just stabilizing CO2 levels is a major challenge.
Which leads to thinking differently about how we measure, like, national success, right? This green GNP idea.
Yeah, it's an interesting concept, basically trying to adjust the gross national product to account for the environmental damage caused by economic activity.
So it's not just about the money flowing, but the actual cost to the planet.
Exactly. It forces you to value things like clean air, clean water, healthy ecosystems, things that traditional economics often overlooks or treats as, well, free.
Okay, so that wider context leads to some core principles for sustainability itself.
It does. The handbook boils it down to recognizing how interconnected everything on the planet is. Nothing just disappears, right? Everything goes somewhere.
Everything ends up somewhere. Got it.
So from that, you get these key ideas. Managing renewable resources sustainably so they can actually renew.
Makes sense.
Recycling non-renewable resources is crucial, keeping our air, water, and soil clean. And really importantly, maintaining biodiversity, the sheer variety of life.
These sound like foundational rules for how we should be interacting with the environment.
They really need to be. They should guide, every decision when it comes to buildings.
Okay, so bringing it down to the actual building level. Where do you even start applying these big ideas? It seems like a huge task.
It can feel that way, but a really good practical place to start is with the materials you choose.
The actual stuff the building's made of.
Exactly. Our sources give this great example from Vadstena in Sweden, a municipal housing company.
Okay, what do they use?
It's quite a list. Solid lightweight concrete, cellular glass insulation, cellulose fiber insulation as well, wood floors, gypsum for the interior walls.
Okay, lots of different things.
Yeah, clay roof tiles, limestone windowsills, tile and expanded clay in the bathrooms, solid wood frames, even coconut fiber for packing around windows.
Coconut fiber. That's specific. It shows you got to think about every little detail.
It really does. But how do you decide if a material is sustainable? It's not just about looks, obviously.
No, definitely not. So what's the process?
The handbook really emphasizes looking at the entire life cycle. That's the key takeaway. You can't just judge a material sitting on a shelf.
Right. You need the whole story.
Exactly. So first up is production. Where's the energy coming from to make it? Fossil fuels, renewables. How much energy?
Okay.
What are the emissions? Air, water, land? Are there byproducts? Can they be used? Is there hazardous waste involved?
Wow. Okay. That's just the making of it. What's next?
Then distribution. Where is it made? How far does it have to travel? How is it shipped? What kind of packaging?
Ah, the packaging. That can be a lot of waste itself.
Huge amount. And a really interesting point they raise is, does the producer take the packaging back? That encourages smarter packaging design.
Good point. Okay, so it arrives on site. What about the actual construction?
That phase has its own impacts. What machinery is needed? What
Yeah.
supplies get used up? Tape, screws, whatever. What are the emissions on site?
Like from generators or trucks?
Yeah. Is hazardous waste generated during building? how much material gets wasted from cutting and fitting,
Wow.
and what happens to the leftovers.
It feels like you need a spreadsheet for every single nail.
Huh, almost. But thinking systematically is key. And beyond the life cycle stuff, there's the health aspect. This is critical.
What's inside the materials themselves?
Exactly. The stuff we use shouldn't contain or, crucially, release dangerous chemicals into the indoor air we breathe.
Because we spend so much time indoors.
Like 90% for many people. So indoor air quality is paramount. And the handbook points out this, like, explosive increase in chemical use globally.
And these chemicals get everywhere, right? Through waste, leaks, even just off-gassing from products.
Totally. Manufacturing, disposal, even just sitting in your house, it's a pervasive issue.
Okay, so let's get specific. What are some good materials, generally speaking? Wood came up in that Swedish example.
Wood's often a good choice, especially if it's sustainably harvested. For floors, softwoods like spruce, pine, aspen, alder, linden work well.
And for walls, like interior paneling.
Most woods are fine if the indoor humidity is pretty stable, but the handbook says be a bit careful with hornbeam, beech, or cherry if humidity swings a lot.
Interesting detail about humidity. What about ceilings?
Pretty similar to walls. Just need to make sure heavier woods, like oak, are really well anchored. And remember, most wood yellows over time.
Except aspen, you said.
Aspen tends to stay lighter, yeah. And spruce is lighter than pine if you're leaving it natural or painting it.
Okay, so wood's got its points. What about gypsum? Also in the Swedish example.
Gypsum gets good marks for sound insulation, heat storage, and fire protection. Useful for plaster, stucco, subfloors, and obviously plasterboard.
Where does it come from?
3 main sources mentioned: natural-minded gypsum. Then there's REA gypsum, a byproduct from tower plants. Apparently it's pretty similar in quality.
And the third one?
Phosphogypsum. That's a byproduct from making phosphate fertilizer.
That sounds
Yeah.
less good.
Yeah, the handbook flags potential issues there. It might contain unwanted heavy metals or even naturally occurring radioactive stuff, so it needs careful checking. REA gypsum is generally seen as fine, though.
Good to know the difference.
Yeah.
Okay, flip side. What materials should we try to avoid? Plastics often get a bad name.
Yeah, and sometimes for good reason. The handbook calls out thermoset plastics like epoxy or bakelite. They're hard to recycle
And epoxy can be allergenic.
before it's hardened, yeah. Polyurethane is another thermoset, releases toxic isocyanates if it burns. Nasty stuff. ABS plastic is also on the avoid list.
So non-recyclability and toxic releases seem to be common themes.
Definitely key things for you to watch out for.
What about PVC? Polyvinyl chloride. It's everywhere in buildings.
Yeah, but it's flagged as one of the most problematic plastics. The chlorine used in production is an issue.
And when it burns.
Releases hydrochloric acid and dioxins. Dioxins are really persistent, nasty pollutants. Plus, mercury is used in making it, though in a closed process.
And additives can leach out.
Yeah, things like phthalate softeners, they don't necessarily stay put in the plastic.
It sounds like PVC has a lot going against it.
Yeah.
It's interesting that there are Swedish databases that rate materials.
Yeah, like Sundah's, ABK's list, Stålbom's handbook, Teknikhandboken.
Yeah.
They offer evaluations.
So resources are out there for people trying to make informed choices.
Definitely. Though the handbook cautions that the evaluations aren't always identical and their methods can differ slightly, so maybe check a couple if you can.
Good advice. What about those other sheet materials mentioned? Calcium silicate and cellular glass.
Right. Calcium silicate made from lime, silicon oxide, cellulose. It's good with heat, helps buffer moisture, resists mold.
Downside.
It takes quite a bit of energy to make. Similar story for cellular glass, that's melted glass with air bubbles.
What are its properties?
Waterproof, non-porous, non-combustible, mold-resistant, lasts ages, but again, high production energy.
But cellular glass had some specific advantages for foundations, didn't it?
Yes, exactly. Because it's strong under compression, you might be able to skip a concrete slab entirely or use a much thinner one.
Really, that's a big deal.
It is. And it stops thermal bridges, heat leaks. Plus, it's tough enough for construction vehicles to drive on. You can get wall and roof elements, too.
Impressive stuff. Okay, windows.
Mhm.
Crucial for energy efficiency.
Hugely important. The handbook talks about standard insulating windows, double or triple glazing.
With air or gas in between.
Right, sealed space with dry air, or, more commonly now, a heavier gas like argon to slow heat transfer. Vacuum glazing is also being worked on.
And stopping too much sun coming in.
Sun protection glass is key for that. Can be absorbing or reflecting types. Some are even electrically controllable.
Cool. What are the frames? Aluminum is common, but how does it stack up?
Making new aluminum takes a massive amount of energy. And the process creates some nasty byproducts.
But recycling it.
Dramatically better, uses less than 5% of the energy. And aluminum lasts basically forever, the life of the building.
Does it need maintenance?
Usually not much, but in polluted air like cities or near industry, it might corrode a bit and need painting or anodizing. So recycled aluminum is definitely the way to go.
Got it. Recycled aluminum. Okay, now for the really wild stuff, seaweed and slate roofing.
Yeah, isn't that amazing? Seaweed, specifically Zostera marina, was used historically. Really thick, steep roofs, like 80 centimeters thick.
And they last it.
For centuries, apparently because of the high silica content. You can even chop some types up and use them as insulation.
Mind blown.
Yeah.
Okay, slate. That's more familiar, but still pretty traditional.
Super durable, last over 100 years easily. Waterproof, resistant to frost, heat, pollution, and old slate tiles can often be reused.
Nice circular economy example. Energy to produce.
It's energy intensive initially, but if you can source it locally, you cut the transport impact. Reusing old tiles is obviously best.
Reusable slate and seaweed roofs lasting centuries. Amazing.
Okay.
Okay, windproofing. Keeping drafts out is essential for efficiency.
Totally. Plasterboard itself is windproof, but you have to seal the joints and edges properly. That's critical.
Are there special types?
Yeah, water repellent kinds exist, often with a wax emulsion. Sometimes they contain fungicides, though. Hard fiberboard is another option for interior windproofing.
And for damp areas.
Oil-tempered or asphalt-impregnated hard fiberboard. Some have a wax coat, too. So it's about careful sealing and picking the right board for the job.
Makes sense. Right, let's step inside. Flooring and interior stuff.
Yeah.
This is what you interact with daily.
Exactly. Floors get hammered, wear, tear, dirt. So cleanability, maintenance, lifespan, all really important.
And floors usually have layers, right?
Typically 3. The structure itself, then a leveling layer called screed, then your actual surface material.
And we talked about glues being potentially problematic.
Yes. The recommendation is definitely to go for low glue or no glue options if possible, like loose laid carpet in small rooms held by the skirting boards, or hidden staples.
Good tip. What about stone floors? They seem durable.
Very hard wearing. Slate, limestone, marble, soapstone, granite are all options. Marble's even naturally antiseptic, good for kitchens, bathrooms.
Sourcing locally is key again.
Cuts down transport emissions, yeah. Just be aware some stone types might emit radon, so that needs checking.
How do you care for stone floors?
Treat them with oil, soap, or wax perhaps, but definitely avoid harsh acidic or alkaline cleaners.
Okay. And the screed underneath.
Yeah.
Sustainable options there.
Screeds can be spread or liquid, self-leveling types. Concrete often needs a screed. The liquid ones use cement Portland or aluminous. Cement production is energy intensive. So the handbook suggests if your base is inorganic, like concrete, use an inorganic screed product. Keep like with like.
Logical. Okay. Wood preservation. Always a tricky one environmentally.
The main aim is to minimize active poisons, basically. Architect Bjorn Burge suggests less toxic options like tar, soda potash mix, green vitriol, though they might need reapplying more often.
And conventional treatments.
Often copper-based, sometimes with chromium and arsenic. That's your typical green-tinted, pressure-treated lumber.
Yeah.
Usually has a Nordic Wood Preservation Council label.
And disposal is important.
Critical. Treated wood waste needs special handling according to local rules. Don't just burn it or landfill it normally.
Right. What about paints and finishes for walls? Eco options.
Definitely. Environmentally certified distemper paints are available to the handbook names some brands.
And avoiding preservatives in canned paint.
Yeah, regular paint often has biocides to stop it going bad in the can. Using paint powder you mix yourself avoids that.
Like traditional distemper.
Exactly. You can use distemper, sometimes with linseed oil or PVAC plastic added, especially for rough exterior wood. Falloon red paint is a classic example, though. The quartz in it means you need breathing protection if sanding.
Mixing on site seems like a good general principle then.
It avoids those in-can preservatives, yes. The sources also gave examples for pipes and gutters, too.
For water and waste.
Right. Polythene pipes were suggested as better than PVC or copper for water and sewage in a raised foam glass insulated foundation.
And gutters.
Wooden gutters and downpipes made from heartwood. Installed overlapping, you can even line them to make them last longer. The handbook also clearly says use concrete or cast iron pipes, avoid asbestos.
Good, clear advice. What about smaller packing materials, like around pipes or windows?
Coconut fiber was mentioned. It's a surplus product globally, but transport is a factor. Mineral wool strips, glass or rock, are common for packing gaps.
And for sealing concrete forms.
Bentonite strips are highlighted as better than PVC ones. Bentonite's a clay that swells with water to make a tight seal.
So even tiny details have greener choices.
Yeah.
The handbook has criteria for evaluating components, right?
Yeah, a useful checklist. Emissions, building process impacts, toxicity, maintenance needs, repairability, recyclability, waste value, and any other notes. Similar Danish systems exist too.
And moisture movement is a recurring theme.
Super important for avoiding rot and mold. Need to understand how moisture travels through walls and roofs.
They even question metal window flashing.
Right, pointing out that historically well-painted heartwood worked fine. It challenges assumptions.
And letting materials breathe.
Yeah, moisture buffering capacity is good for indoor climate. Avoid totally waterproof interior finishes that trap moisture. They even showed a breathable wet room wall made of porous brick, and a building mostly of wood.
That's radical compared to standard wet room construction. What about basements and raised foundations, moisture magnets?
Definitely. For basements, good drainage outside, vapor barriers, and crucially, insulation on the outside of the load-bearing wall.
And for raised, suspended foundations.
Avoid organic materials underneath. Use moisture-tolerant stuff like foam glass or wood wool cement board. And that warm, suspended foundation idea is interesting.
Ventilating with inside air.
Exactly. Insulate it well from the ground and sides. Then ventilate the crawl space with warm indoor air, either actively with exhaust air or passively through small gaps. Keeps it warmer and drier.
So all these material and design choices link back to bigger issues.
Absolutely. The handbook connects them to raw material shortages, the sheer volume of construction demolition waste, like a third of all waste, the fact that pure materials are easier to recycle.
And even in super efficient buildings, the materials themselves represent significant resource use.
Right. Plus, how climate change might affect where we can even build in the future.
That waste figure is staggering, a third of all waste.
It really is. Which is why designing for disassembly is so important.
Taking buildings apart carefully at the end.
Exactly. Using things like screw piles, separable blocks, click-together timber systems, demountable floors and beams, special tape for plasterboard, it makes reuse and recycling much easier.
Thinking cyclically. Okay, let's pivot to energy efficiency and building systems. Lots of practical stuff here for you listening.
Yeah, this is key. Ventilation systems have evolved. Exhaust air heat pumps were big in the 80s, 90s, though some had freon issues. Then fan-assisted natural ventilation came in using thermostats and sensors.
Preheating the incoming fresh air seems smart. How?
Solar walls are one-way air drawn behind dark, glazed panels warmed by the sun, or drawing air behind dark cladding on south walls or roofs. Even some radiators are designed to preheat intake air.
Using the building itself. Clever. What about electrics? Health concerns around electromagnetic fields.
Yeah, it's a topic that comes up. Alternating current creates fields. The advice is to install wiring to minimize these fields. Sources aren't just in the building, though power lines, phone masts too.
So, practical installation tips.
Standard plastic conduits don't shield fields, so you can get electric fields in walls. Shielded electrical systems reduce this. Also, newer 5-wire systems, separate neutral earth, are better than older 4-wire, combined PEN.
Are there special cables?
Superlorus shielded cable is mentioned for blocking fields, and using earth sockets, metal junction boxes, switches, plugs is recommended.
Okay. And bathroom plumbing preventing leaks seems like a sustainability issue too. Less damage, less waste.
Definitely. Avoid screws and pipe penetrations in splash zones. Design wet rooms so pipes don't go through the floor if possible. Seal any necessary penetrations carefully. Avoid screws near showers.
Common sense, but needs careful planning.
What about storage tanks for renewable heat, solar thermal, biomass?
Essential for storing heat generated, right, for use later. They often have multiple heat exchanger coils for different inputs, solar, boiler, electric backup maybe.
And you can add more tanks.
Yeah. Slave tanks can expand capacity. Usually steel need pressure certification, can get cellulose insulation for them, need safety valves, of course. Basically the heat battery. What about less common heating? Underfloor heating in the ground. Hypocaustes.
Older ground heating pipes can leak. The German Hypocaust circulating hot air from a stove is used in some eco-builds. Good heat, but costly, can restrict layout.
And using just a wood stove's radiant heat.
Can work in super insulated, open-plan homes, need ways to distribute the heat ducts, fans, long flues, finish partition walls with chimney channels, German hypocaust variations using brick channels. Lots of ideas there.
Now, you mentioned a warning about cellulose insulation in lofts. Mold risk.
Yes, but it's important It's not the cellulose itself. It happens if the building's vapor barrier isn't properly airtight. Warm, moist air leaks up, condenses on the cold roof underside.
So airtightness is still key, even with breathable construction.
Absolutely. You need specific airtight materials and meticulous sealing of joints and penetrations.
Where else do leaks typically happen in basic construction?
Pipe penetrations are common culprits. Concrete basement walls, if not sealed well. Drainage hoses from damp-proof courses connected to ventilation pipes need a fan there if using for radon mitigation.
Speaking of radon, other ways to deal with it besides sub-slab ventilation?
Ventilated air gaps in floors or basement walls can help draw it away. Absolutely airtight pipe penetrations are vital. Sometimes building an additional slab is an option,
Okay. Sound reduction, also important for quality of life.
especially in denser areas. Noise is a big stressor. Sweden has a sound standard, including low frequencies. Heavier building systems generally make it easier to meet these stricter standards.
And just keeping the place clean. How does design help?
Seems minor, but makes a difference. Good dirt traps at entrances, grates, mats, pillars near walls, not obstructing cleaning paths, wall-hung toilet sinks, bathtubs without fronts, fixtures high enough off the floor, avoiding pipes through floors.
Makes cleaning much easier. And using eco-friendly cleaning products.
Definitely recommended. Use certified ones. Reliable lists are available to help choose good products and avoid hazardous ones.
It all adds up. This leads to needing environmental planning right from the project start.
Totally. An environmental plan should be part of quality assurance. Environmental issues cross disciplines, so clear control and responsibility are needed early on.
Choosing an evaluation system, using a handbook, planning checks.
All key steps. Tools like LegitP for life cycle performance and BIM, building information modeling, are really useful here.
BIM lets you embed environmental data in the digital model.
Yeah, you can model energy use, do life cycle analysis, track materials, all within the design process. Very powerful.
And when buying stuff, procurement.
Set environmental requirements early for specific functions and then follow up. The tendering process is crucial too. Clear invitations, contractor bids, clarifications, documenting negotiations.
Avoid misunderstandings later.
Exactly. And record any changes made. Then, the final inspection and handover
Finish line.
needs to be thorough.
Yeah.
Detailed inspection report. And importantly, clear, simple operating instructions for environmentally responsible management, plus all the material certifications.
Cost is always a factor. Can sustainable building be cheaper?
It doesn't have to be more expensive up front and often saves money long term. Reducing size, compact design, simple structure, efficient methods all help cut initial costs.
The Boloff is example.
Yeah, IKEA Skanska. High standard, lower cost, partly through resident involvement and upkeep. Smart design and efficiency can be affordable.
Going back to the end of life. Selective dismantling.
Yes, carefully taking buildings apart to recover materials for reuse or recycling. Seeing demolition waste as a resource bank. Regulations are evolving to support this.
Okay, let's focus deeper on energy efficiency strategies.
3 key areas: architecture itself, shape, zoning, heat storage, passive solar cooling. Then the building shell insulation, windows, airtightness, that's huge. And third, heat recovery from ventilation.
And efficient electricity use.
Crucial. Avoid electric heating if possible. Use efficient appliances, lighting with controls. Prioritize non-electric, daylight, cool larders, natural ventilation for drying clothes.
It's a mindset shift. Minimize first. How much can we realistically save?
Sources suggest 50% reduction is possible, even with some growth in consumption. Depends on policy, though. The Factor 4 idea is ambitious. Quadruple wealth, have resource use.
Wow. Is that even achievable?
It's a target, but the handbook gives that example of the Lindos terraced houses in Gothenburg. So efficient, internal heat gains are often enough.
No main heating system.
Basically, no. Small electric preheater for intake air in deep cold, but mostly body heat, sun, appliances, hot water, keep it warm. Shows what's possible.
Amazing. What are the official Swedish passive house energy targets?
Very strict. Around 45, 55 kilowatts per square meter per year, including household electricity. Normal new builds are more like 110, 130, excluding household electricity.
So passive houses are much tougher. Insulation thickness is key for that. Is there an optimum?
There's an economic optimum, yeah.
Yeah.
Balancing the cost of thicker insulation against future energy savings. As energy prices rise, thicker insulation becomes more cost-effective.
We mentioned exhaust air heat pumps earlier. Pros and cons.
They recover heat from outgoing air for hot water, maybe some space heating. Advantage: no separate intake exhaust ducts needed. Downsides can be prone to breakdown, higher initial cost. Maybe not best for super efficient homes, more for larger buildings.
And recovering heat from multiple chimneys and apartment blocks.
Yeah, centralized heat recovery is possible there.
What about wastewater heat recovery, capturing heat from drains?
Exactly. Preheats incoming cold water, using heat from shower dish water, etc. Good for places with high hot water use like swimming pools, but also tested in efficient homes. Every little bit helps.
Even laundry appliances have improved massively.
Hugely. Energy use dropped like tenfold from the 90s to early 2000s. Can make sense to replace older machines even if they still work. Water efficiency too, recirculating models, load sensors.
Technology helps there. What about that ecological kitchen design from '93?
It had forward-thinking features for its time. Future kitchens might have insulated pans with built-in heaters, gas stoves, super insulated ovens in various sizes.
Targeted heating, better insulation. Makes sense. Lighting, big energy user.
Needs a thought-through system. Controls, sources, fixtures. Consider light needs, quality, brightness control. LEDs are obviously big now.
Replacing incandescence and fluorescence.
Yeah, direct replacements exist. Some LED tubes work in fluorescent fittings, maybe needing ballast bypass. Many are dimmable. But check actual light output versus advertised lumens sometime.
Good point. And standby power waste, TVs, chargers.
Adds up significantly. Look for Energy Star or TCO labels. They often have better standby modes. Trend is towards more efficient equipment, generally pumps, fans too.
Office equipment, copiers.
Copiers are often big energy hogs. Choose efficient models, turn off when not in use. Look for certifications covering more than just energy, emissions, materials. Tips: right size, power control, double-sided printing, standby modes, sensible monitor size, screensavers. Consider laptops.
And daylighting, free light.
And beautiful light. Light entering high up is much more effective, like 4 times more than low down.
Light shelves.
Bounce light deeper into the room while shading near the window. There's even tech like Perrin's daylight to pipe sunlight into deep building interiors.
So maximizing daylight saves electricity and offers architectural possibilities. Windows, skylights, atriums.
Ralph Erskine's periscope idea too, for light and views.
Finally, hot water heaters. What makes them sustainable?
Good insulation is key, at least 6 centimeters recommended for new ones. Older ones lose a lot of heat. Durability matters too.
Anything to watch out for?
Enamel-coated tanks in combi boilers can fail more often. Need to replace the galvanic anode regularly, every 3 years maybe, to prevent corrosion. Key factors: adequate supply, good insulation, low consumption, accessible control.
Better insulation, regular maintenance. Okay, let's shift to water and waste management in sustainable buildings.
Crucial topics. Protecting water sources is paramount. Groundwater can be contaminated by sewage, manure, timber yards, farmland runoff, road spills, salt, garden chemicals.
So keep wells away from potential pollution sources.
Rule of thumb is maybe 50 meters. Deeper groundwater is usually better quality. Deep rock well, generally better than shallow-driven wells.
How to get water up sustainably.
Wind pumps are an option. Simple hand pumps with cisterns are great for backup or off-grid. The India Mark II pump is mentioned as very durable.
What about the sheer amount of waste we generate as a society?
It's huge. Sweden has good recycling rates and goals, but overall consumption is still high. Incineration recovers energy, but cleaner emissions depend on good sorting first.
Landfills are problematic.
Leachate polluted water seeping out is a major issue, needs treatment. Better sorting reduces hazardous waste ending up there too.
Producer responsibility helps tackle waste at source.
Yeah, making manufacturers responsible for end-of-life products, packaging, tires, paper, cars, electronics, encourages eco-design, reuse, recycling.
Needs good sorting systems everywhere.
Homes, work, recycling centers all need to integrate with municipal systems. Needs planning in buildings. And dedicated facilities for hazardous household waste are essential, plus special recycling for electronics, batteries, light.
Can we turn waste into energy? Biogas.
Yes, fermenting organic waste like crops or manure produces biogas fuel. The leftover digestate is fertilizer. Crops like alfalfa, reed, canary grass work well. Sweden has potential for energy crops.
And kitchen boilers. Wood-fired cookers that also heat water.
Becoming popular in efficient homes. Do cooking and heating. More certified models available now.
Okay, moving to renewable energy generation. Solar thermal collectors.
Well established for water heating. Swedish ones like Sunstrip are high quality. 5 square meters might cover half a home's hot water. Larger systems for space heating too. Prefab or roof integrated. Simpler ones for summer cottages. Reflectors boost efficiency.
And large-scale storage. That airport aquifer.
Arlanda Airport stores summer cold for cooling, winter warmth for heating in a groundwater aquifer. Clever. White architects use cold lake water for cooling their Stockholm office.
District heating cooling is common in cities.
Often uses biomass or large heat pumps. District cooling networks are growing too. Heat pump tech for individual AC is common. Window wall units, split systems, ducted. Efficiency varies.
Combined heat and power, CHP. Generating electricity and heat together.
Biomass gasification feeding gas turbines. Then steam turbines electricity at 2 stages. Waste heat for district heating. Very efficient. Smaller scale CHP uses natural gas and Stirling engines. Pellet-fueled versions exist too.
Stirling engines again. How do they work simply?
Closed system. Gas heated cooled to move a piston crankshaft. Combustion is external via heat exchanger. Can recover waste heat well.
Wind tower. Growing fast globally.
Major turbine makers worldwide. Specific process in Sweden if you want your own turbine.
Wave power. Still emerging.
More experimental. Various designs tested. Sea worms in Scotland, floating systems in Denmark, buoy platforms in Norway. Portugal had the first commercial park using Pelamis tech.
And solar cells, photovoltaics, PV. How do they work?
Photons from sunlight hit silicon usually, knocking electrons loose, creating electric current.
Different types.
3 generations usually mentioned. First gen, crystalline silicon, most common, 13% efficient. Second gen, thin film, can be cheaper. Third gen, nanostructured, research stage.
Huge potential for solar.
Massive. Sahara Desert example shows the scale. Need to cut costs. We're seeing more building integrated PV tracking systems, concentrating solar power plants using mirrors and turbines, like Edge UGS in California.
Exciting developments. Okay, final section. Pulling back to sustainable communities and planning. How does it all fit together?
Individual sustainable buildings need supportive communities and planning. For wastewater, separating different streams allows targeted treatment. Hammarby Sjöstad in Stockholm is a prime example.
What do they do there?
Separate rainwater, traffic water, sewage, local runoff management, special sludge purification. Biogas from sludge food waste fuel stove scars. Purified sewage water feeds district heating via heat pump. They even oxygenate the lake. Norra Djurgårdsstaden is another eco-focused district.
Amazing integration. What about permaculture principles?
A whole design philosophy. Work with nature, observe patterns, multiple functions for elements, use biological resources, energy efficiency, renewables, water focus, perennials, natural succession, animals, durability, adaptability. Really holistic.
And bringing green into cities. Green wedges.
Strips connecting urban areas to natural wilderness. Maximizes biodiversity-rich edge zones. A Helsinki housing proposal used 3 levels of green wedges.
So important for well-being and nature in cities.
Crucial. And need to protect existing vegetation during construction trees, roots, water flow. Vegetation on and around buildings helps too. Vertical gardens like Patrick Blank's are fascinating.
We also need to consider water health, blue-green algae blooms, and food production.
Organic farming helps no artificial fertilizers, pesticides, less energy, more biodiversity. Sustainable forestry certifications like FSC ensure responsible management.
What about tricky building conditions? Clay soil.
Difficult for foundations, settling issues. Solutions exist. Piles, floating foundations, compensation method. Service pipes tricky too.
Road construction impacts.
Big land alteration affects drainage. Need to plan for heavy rain, flooding, erosion. Grouping service pipes under roads helps minimize impact. Shallow or insulated pipes for sewage, maybe pressurized systems to reduce trench depth.
Managing rainwater locally.
Better than mixing with sewage. Let it soak in or go to local water bodies. Detention ponds for flood control. Also, avoid building in cold air lakes, valley bottoms. Mitigation possible sometimes.
Bringing all this together requires municipal coordination.
Absolutely. Need holistic approach, break down departmental silos, foster discussion, critiques large-scale centralization favoring transport over local distinctiveness. Contrasts U.S. car-dependent cities with more balanced European ones.
Like Houghton in the Netherlands.
Great example. Separated car-back traffic, good cycle paths, short distances. Good public transport is vital light rail, train trams like Karlsruhe, efficient trains. Copenhagen's cycle paths are famous.
Cars won't disappear entirely.
Probably not. Focus on reduction, cleaner vehicles, plug-in hybrids, smart parking like Amsterdam Silendam helps, small city EVs like in Livorno. Freight by train is efficient, need good transshipment hubs. Boat transport too, though emissions need tackling.
Hammarby Sjöstad keeps coming up as a case study.
Shows how integrated planning reduces energy water needs, uses waste for biogas sheet. Really advanced thinking.
So what defines a truly sustainable municipality?
Close town-country relationship, closed ecological cycles, efficient local resource use, nutrient retention, minimized climate impact, stimulated local culture economy. Not self-sufficient, but optimizing locally.
Protecting water wetlands is key.
Vital for drinking water, nutrient trapping. Need diverse water planning, ground surface rain. Consider aquaculture, hydro, wave, wind power too.
Core principles for sustainable cities.
Integrate with surroundings, protect valuable land, concentrate development wisely, balance density decentralization, link urban structure and transport, use bioclimatic design, prioritize green water spaces, create green corridors,
And waste is a resource.
minimize non-organic, reuse, recycle, handle toxic waste carefully, recycle nutrients from organic waste, biogas compost, burn waste for cogeneration, recycle paper fiber.
Finally, traffic and development plans.
Traffic plans cover people goods movement, road hierarchies. Development plans locate functions together, discourage segregation, make workplaces accessible, avoid out-of-town malls, put amenities nearby, keep city centers vital, preserve existing structures. The goal, an eco-community.
Wow, that was a truly deep dive. We've gone from global climate concerns right down to specific material choices like seaweed roofing and back up to planning entire sustainable cities.
It really shows how interconnected everything is, doesn't it? You can't really isolate one aspect. Materials, energy, water, waste, community design, it all has to work together for truly sustainable, healthy places.
Yeah, it's not just about one silver bullet. Some things that really jumped out were, yeah, the seaweed roofs, definitely, but also the sheer efficiency gains in things like washing machines.
It shows progress is possible on many fronts. And the integrated systems, like at Hammarby Sjöstad, turning waste streams into valuable resources, that's really inspiring.
And that factor 4 idea, quadrupling wealth while having resource use. A huge challenge, but maybe necessary.
Hopefully, this exploration has given you, the listener, a clearer map of this complex territory. Maybe sparking ideas for your own context, whether it's a home project or just understanding your town better.
Absolutely.
Yeah.
And maybe it leaves you with this final thought to chew on. What if we genuinely treated every single building not as an isolated object, but as a fully integrated part of its local ecosystem, and the global one too?
If that was the starting point for everything we designed and built, what kind of innovations might that unlock? Something to think about.
Definitely something to think about. Thanks for joining us on the Deep Dive.